All right, here's the homework for the first of the three 4.5 homework assignments. I probably didn't need to split these up into three different homework assignments, and maybe I didn't need to space them out as much as I did. But I just know in the past people have had a really hard time with 4.5, so I thought maybe allotting more time here would help. We've kind of gone fast through some other stuff that typically goes better for students. I don't know. It's a work in progress. Hopefully, this is working for you guys. Anyways, the first of the 4.5 sections deals with just normal CDF. What we'll see in 4.5 is we can also do confidence intervals and hypothesis testing, but not in this video. For normal CDF, there's 5 questions here, although really there's only 3, as you'll see when we go through. The first 2 are just kind of setting the stage for what 4.5 is all about. So the idea in 4.5 is for you to get comfortable that we can now analyze data that's not numeric. That's this categorical, or specifically binary categorical data. So picture if you were collecting data in each of these instances, what the question is asking you is, would your data be a whole bunch of numbers like it's been in the past so that you could calculate a mean? Think the number of pepperoni on a pizza if you want. Or would it be a whole bunch of yeses and nos, in which case you can determine the proportion of your sample that said yes. So for example, a poll shows that 64% of Americans worry a great deal about federal spending and the budget deficit. So if you went out and got a sample of 100 people, each observation, each person would either say yes or no. I'd say, do you worry a great deal about federal spending and the budget deficit? And you might be like, nope. And the next person would say, nope. And the next person would say, yes. Nobody would say, well, yes, on a scale of 1 to 10, I worry about this a level of 7. Right? If they said that, then it would be a mean. But they're not. This is a yes or no thing. These are proportions. Read through all of these and try to determine if it's mean or proportion. And sometimes they're a little bit tricky. Sometimes they'll throw percentages in there to kind of try to mess with you. Read through them, see if you can be comfortable with the differences between the two. I think that'll set the stage pretty well for the next couple of sections. Second question. Oh, I guess I lied. I thought the first 2 were the same. I guess the first 2 are not the same. Maybe I got rid of. It used to be that there were 2 of these, but I guess I figured the 5 that you get in the first question is more than enough. Anyways, the second question. Suppose the true proportion of voters in the county who support a school levy, so here's my population proportion, we use the letter P to represent that, is 0.44. Consider the sampling distribution for the proportion of supporters with sample size n equals 161. So sampling distribution for the sample proportion, so this is what we're talking about in 4.5, and they give us the sample size n, so I have n and p. And when you have N and P, they can ask you questions like, what is the center and what is the spread? They're saying the mean of this distribution of the proportion of the sampling distribution for the proportion of supporters. Center and spread is essentially what they're looking for there. So if you know the formulas for center and spread, you can type those in and you can get your answer. Note that it wants these as decimals, not as percentages. So don't go translating these into percentages. Question number 3. Newts. Back to newts again for some reason. You're not actually calculating probabilities in this question, just like on the previous one. So you're not going to be using any normal CDF or anything. You won't use that until 4 or 5. It's another one where you're just kind of setting up the problem. So the idea here, as you've seen before, is they want you putting the numbers in the boxes. So if you know the center, you can put that in this box. And if you know the spread, you can count up twice by the spread. So start with the mean and add twice the standard error, aka the spread of the sampling distribution of the sample proportion. That was kind of a mess. And that'll give you this number. And subtract it twice, and that will get you this number. And hopefully they give me both P and N in this problem so I can do it. Let's see if I read through it. It says 40% are born green. That sounds like P. And with a sample of 201 of these little guys, that sounds like N. I know N and P. I can get the center and the spread. Type them into the boxes. Question 4. We're actually doing the problem here. What is the probability that? All right, we're finally going to actually answer a question. But before you do so, they ask you to kind of set it up. And what they're trying to emulate here, I don't know if they did a great job, is shape, center, spread. So this first question, is the sample size large enough, is pretty vague. But what they're getting at here is, in order to do this question, I need the shape of the sampling distribution for the sample proportion, this thing we're talking about, to be normal. And maybe you remember we have a criteria for that. It's n times p times 1 minus p has to be greater than or equal to 10. Is the sample size large enough? Guess what? It's going to be yes. Because if the answer was no, you couldn't do the rest of the problem. It has to be yes. But you could check it if you want. You could take n and multiply it by p and multiply that by 1 minus p. And I bet you'll get a number that's greater than or equal to 10. And that will tell you to put a yes up here. This will be your center and this will be your spread. Maybe you recognize these fancy symbols from the video. This is the center of the sampling distribution for the sample proportion. A lot to say. And this is the spread of that guy. So you got formulas for these in terms of N's and P's. Put them in there. And then this one. Okay, so this is kind of tricky. Suppose we find from our sample that 147 out of these 175 people will vote for this candidate. Give P hat. If you go back to that video, you might see that we define the symbol P hat. It represents the sample proportion. You're like 147? No, this is the count in the sample that supports this thing. The proportion would be 147 out of 175. Just like in the video when I said 50 out of 200 Irish people with blue eyes, we didn't want to state the 50. We wanted to state the 25%, the 50 divided by 200. Same idea here. What I'm trying to get at is P hat will be 147 divided by 175. And the reason they have you calculate that there is when you read this question, what is the probability that at least 147 people will vote for this candidate? Ignore this hint. That doesn't help you. You don't use Excel. What is the probability that at least 147 people? Don't think about it as 147 people. Think about the proportion that is represented by 147 people. What is 147 out of 175? Conveniently, you just calculated that up here. You'll use not Normdist, but instead Normcdf. And as long as you have the lower bound and upper bound, and then the center and the spread, you can get your answer for this. And then finally, question 5, if I remember right, is pretty similar to question 4, except they don't have you do the whole setup part of it. Right? So they don't have you do the shape, center, spread, all that kind of stuff. You just read through the problem and what is the probability that, there's our hint that it's Normcdf, although I guess in this section, everything's Normcdf. What is the probability that the sample proportion will be at least 5% more than the population proportion? Okay, that's an annoying way to ask a question, but I suppose we can make sense of it. Assume the population proportion is 75%. There's P. What they're asking you is what is the probability that our sample proportion will be more than 80%? Ooh, where'd that 80% come from? 5% more than 75%. I'll never ask a question this way. If this were on a test, I'd say, what is the probability that the sample proportion will be at least 80%? But they don't. They say 5% more. They mean 80%. Hopefully in here, they give you P and they give you N so that you can answer the question. So another Normcdf one. And that's this homework.